Okay, next is decision tree. Okay, so we need R part and R part dot plot, and okay. Now, decision tree, you don't need any data preparation at all, except maybe missing value. Even that missing value can be treated as a value in decision tree. You don't even have to impute when running a decision tree. But let's not get to that. So we're going to go back to the original data, as is, no dummy variables, no normalization, no nothing. Okay, so we go back to the original, which already has the missing values already imputed. Okay, and we split the data into trained and valid. Okay, and of course there are several ways in which we can develop tree. You can specify particular parameters, like you want minimum split, maximum tree, how many nodes you want, and all of that stuff. Okay, it's there in the class notes. But here I'm going to illustrate the best CP tree. So we're going to run the full tree and then look for X error. So we're going to run cross-validation. So X error is cross-validation error. So cross-validation error, the least cross-validation error, okay, and corresponding to that smallest cross-validation error, we're going to look at what the CP value is, and we'll use that CP value for pruning. Okay, so we have the full tree, and you get the full tree when you use CP equal to 0 and min split equal to 1. That's what is going to give you the full tree. Okay, and then xval here is the number of folds in cross-validation. Okay. And then here are the two code for length of the tree and length of I'm sorry, the number of nodes in the tree and the number of leaf nodes. Okay. And then print CP is going to give you the table of X error. Okay. So here is the X error, and then we're going to look at the CP table. Okay, so this is the CP table, and we're going to look at X error. So we're going to look at that table, and then we're going to find what the minimum value is. And then we're going to look at the minimum value. You know, we could have used which min here, I guess. Which min of that will also give you the same thing. And then once you have the row corresponding with the minimum error, then you go to that row and get the value of CP from the CP column. And that will be our best CP. Okay, now it has two of them. If you look at these two, they both have the same X error. So we're going to use the first one. That's the reason why we have best CP. So best CP here, there are two. So if you look at best CP, see there are two values in there. So we'll use the first one. Okay, and so best CP tree. Okay, you take the full tree and prune it using by setting CP equal to the best CP. So here's best CP1. and then you print everything. Okay. So now we have the tree. Okay. Now if you want to develop a tree for specific parameters, so you want to use rpart.control for that. Suppose you want minimum split to be 50 and maximum depth to be 15. You set that up as a control and then use rpart. Then you'll have a new tree here. Okay, and you can play with the type and extra to generate your tree the way you like. Okay, so this one is good because it tells you exactly how the branches are split, and then you can do a rules. So that's going to give you the rules. Okay. And then you want to do prediction. Suppose if this is a new record, okay, and you want to predict for this new record. So you have to use the rules here, or you can use the tree. Okay. So the root node is width. Okay. So width in millimeter, so that is 6.8. So this is less than 6.4, so this side is where you have to go for the new record, 6.8. And then clarity, so the next one is clarity, okay, VVS2. Okay, so clarity, so VVS2 is on the left side, so you get to that point. Okay. The next variable is cut, so go to cut. See, cut is fair, so cut, so well, it's abbreviating to just 3 letters, and that's to do with the, I think this extra. If you change this extra to something, it will print the whole thing. Fair is this side. So now we have come to the leaf node. Okay. So some of the rules may not use all the values of the predictors. It may not use all the predictors. It may use only some. So here it's used only few, and that one is 0. So here, what are these numbers? 36 out of 39 or 0. So there are 39 observations here. That 2% says that there are 2%. What we start out with, okay, so we start, I don't know how many we start out with. We have only 2% of the observations in this node. And of that, 36 of 39 are zeros. So your prediction probability here is, okay, so here this is the one. This is the rule that satisfies our record. So the probability of high margin equal to 1 is 8%. Okay, so this is the rule. So here the rule used is this. Rule used is this one. The probability is 0.08. So our predicted class is 0 for high margin. Okay. So this is if you want to predict one record, but to predict a bunch of records, then you use the predict method and give the trained model object. Okay, once again, if you say type equal to class, it's going to give you class. Type equal to prob will give you the probability. So depending upon what you want confusion matrix, you use class. For ROC chart, you use probability.